You are listening to The Vocal Technologist. Spoken tech for your ears.
Okay, so usually when we talk about the software engineering landscape, there's this underlying assumption of, total human control.
Right. Yeah, like we're the ones driving.
Exactly. I mean, think of a physical construction site for a second. You have engineers, they show up with their tools, and they build the building according to the blueprints. And when they're done, the building just stays put. You can see the crane, you can see the scaffolding. Like, the human is the conscious actor, and the tool is just, it's just a piece of unthinking metal.
Yeah, I mean, the relationship has always been completely deterministic. We issue a command, and the machine executes it to the letter.
Right.
So if a system fails or, a vulnerability gets exploited, it's almost always because a human typed the wrong command or just made a logical error.
But looking at the massive stack of late May 2026 DevOps and architecture newsletters we brought in for today's deep dive into our sources, it really feels like that entire construction site is violently shifting under our feet.
It absolutely is.
The tools are waking up. We're officially moving from this era of humans using static tools to, an era of autonomous AI agents acting as independent builders and, terrifyingly, as autonomous attackers.
It's a really profound and just a rapid transition. And to set the baseline for you listening right now, today we are looking at the absolute bleeding edge of cloud infrastructure, system security, and automation.
Yeah, the really heavy stuff.
Right. We've combed through dozens of dense technical reports and architecture updates to extract the most critical so what insights. Because the goal here is to help you understand the architectural reality of what happens when AI stops being just a helpful chatbot in your browser.
Right, and starts becoming an independent actor just roaming around inside our networks.
Exactly. We're going to decode the mechanisms behind this shift so you don't have to wade through the raw data yourself.
So what does this actually mean in practice? Let's just jump right into the deep end here, because on May 10th, the SysDig threat research team documented something that genuinely made my jaw drop.
Oh, yeah. The Marimo incident.
Yeah. They witnessed what appears to be the very first fully documented, completely autonomous AI agent-driven cyber attack in the wild.
And, the sheer speed of the execution is what should give literally every engineering team pause right now.
Yeah, how fast was it?
Well, the attacker found an open vulnerability in a Marimo notebook. And for context, a Marimo notebook is this reactive Python programming environment.
Okay.
So data scientists and developers use them to write code, visualize data, share interactive documents. They're incredibly useful, but, and this is the key, they run live code.
Ah, gotcha.
Yeah, so in this specific case, an exploit known as CVE 2026-39987 was just left exposed.
And once the AI found that open door, what actually happened?
So from that initial access point, a large language model autonomously navigated the host environment. I mean, it didn't just execute a single script or command. It actively looked around, compromised the underlying AWS credentials, and managed to exfiltrate an entire PostgreSQL database.
Oh my God.
And the total time from the initial point of entry to the complete theft of the data was under 2 minutes.
Okay, let's unpack this. It's like a burglar who doesn't just pick the lock to your front door. It's a burglar who breaks in, realizes they're in the hallway, and then actively reads the architectural blueprints of your house on the fly.
All to calculate the exact structural path to the hidden wall safe in the basement, yes.
Exactly. But wait, let me push back on this for a second. How do we know this wasn't just a really sophisticated, pre-written script? I mean, automated lightning-fast attacks aren't exactly a new concept in cybersecurity.
That's a great question, and it's a crucial distinction to make. Like, how do we know it was an AI actually thinking and not just a script running?
Right.
The sources highlight 4 key forensic signatures that prove this was real-time AI composition. First, the agent attempted to dump a database table called credential.
Okay, that seems normal for a hack.
But that table didn't actually exist in the victim's database. Yeah, the AI made a logical schema assumption based on the environment it was exploring. A static script would only look for exactly what it was programmed to find, right? But this entity was dynamically guessing based on context.
That implies, a level of independent reasoning. What were the other signatures?
So the second one is almost surreal. The agent accidentally left behind a Chinese language internal monologue in the server logs mid-attack.
Wait, really?
Yeah, it was a literal artifact of the LLM thinking through its next steps, translated and dumped into the system's execution logs by mistake.
Wow, it literally dropped its own train of thought right at the crime scene.
It did. And third, the terminal commands use distinctively AI-formatted syntax. We're talking about specific text separators and bounded data captures that human engineers or traditional scripts simply do not write.
Interesting. And the fourth?
The most definitive proof. The agent was dynamically chaining its outputs. So it took the result of one server command, reasoned about what that output meant, and used it as the input for the next command.
That's nuts.
And it did all of this while spreading its network requests across multiple Cloudflare workers' IP addresses just to evade security detection.
But how does an agent even know which commands to chain together without a human guiding it? Historically, a hacker has to sit there, look at the error message, and figure out the next move.
That is the terrifying part. And it connects directly to research Anthropic just released regarding their Project Glasswing and the Claude Mythos preview.
Oh, I read about that.
Yeah. Cloudflare's analysis of these new models shows that AI fundamentally changes the economics of vulnerability discovery. Historically, a human attacker might find a low-severity issue, say, like a minor configuration error, and just ignore it because it wasn't worth the manual effort to exploit.
Right, it's too much work for too little payoff.
Precisely. But an AI agent doesn't get tired. It can rapidly chain 3 or 4 of those seemingly harmless, low-severity issues together to create a critical system-destroying exploit. And it generates the custom proof-of-concept code on the fly in milliseconds.
Which means the attackers are moving at a speed and scale that human defenders physically cannot match. I mean, if an attack takes under 2 minutes from breach to full data exfiltration, a human security analyst won't even have time to get the alert on their phone, let alone stop it.
Exactly.
So the logical transition here is pretty stark. Companies are realizing that to fight autonomous malicious agents, they have to build a massive internal infrastructure to harness their own good AI agents just to keep up.
It's really the only viable response right now.
Yeah.
You have to fight automation with automation. But housing these defensive AI agents safely requires entirely new infrastructure architectures.
Like what?
Well, take Dropbox, for example. The sources detail their new internal cloud platform called Nova, which is specifically designed for running coding agents.
Wait, so we're intentionally giving an AI agent access to our proprietary code base?
Yes, but in a highly controlled quarantine. Nova allows engineers to run multiple AI coding sessions in parallel, but it puts these agents in heavily isolated environments.
Okay, so they're locked down.
Right. They pin the agent to a specific repository commit, meaning the AI can only see a frozen snapshot of the code at one specific moment in time. Then they validate any changes the agent proposes using Bazel-backed build and test commands.
Okay, let's break that down. For anyone not living in the DevOps trenches every day, what makes a Bazel-backed environment so important for an AI?
Sure. So Bazel is a build system originally developed by Google that operates in what we call a hermetic environment.
Hermetic, like an airtight seal.
Exactly. That means it isolates the build process entirely from the rest of the host system. It guarantees that the same input will always produce the exact same output without any hidden dependencies sneaking in.
Got it.
So when the AI agent in Nova suggests a code change, Bazel attempts to build and test it in this hermetic bubble.
And what if the AI writes bad code and breaks the build?
That is the brilliant part. If the agent fails the test, Nova automatically feeds that specific error log back into the AI session so the agent can try to fix its own mistake, completely independent of human oversight.
Oh, wow. So we're essentially building specialized, hermetically sealed playpens for these AI coding agents so they don't accidentally take down production while they're trying to help us.
That's one approach, yes.
Yep.
Another is what we see with AWS Bedrock Agent Core.
Hmm.
We're seeing a massive trend where teams are deploying these agent runtimes via Terraform.
Right, Terraform.
Yeah, Terraform is an infrastructure as code tool. It means engineers write configuration files that dictate exactly how much memory, network access, and processing power an environment has.
Okay.
And they're using Terraform to dynamically spin up and tear down these digital cages for AI agents on demand.
But we're also seeing AWS launch the next generation of Resilience Hub, right?
Yeah.
Which uses generative AI-based site reliability engineering to monitor these systems.
Yes, and the scale is staggering. AWS is using AI-powered failure mode analysis to set organization-wide goals, like 99.95% availability SLOs.
An SLO is a service level objective, right?
Basically, a hard metric promising that a system will almost never go down. They are trusting AI to analyze the architecture and tell them how to meet that near-perfect uptime.
Okay, I have to ask the obvious question here. we're building these elaborate sandboxes and trusting AI to monitor our entire cloud uptime. But how smart are these AI brains, really, when they are inside these sandboxes?
Well, if you look at the source titled Agent Memory and Anatomy, you realize that an AI agent's brain is fundamentally flawed.
Really? How so?
It isn't anything like human memory. It's a very clunky mechanical pipeline of extraction, storage, and retrieval. When an AI agent has a conversation or reads a log, it doesn't really remember it.
What does it do then?
It uses a library to extract what it perceives as facts, compresses those facts, and stores them mathematically in a vector database or a graph.
And anytime you compress something, you lose nuance and detail.
Exactly. Because of this mechanical extraction, these agents deeply struggle with contradictions. They suffer constantly from stale context.
Meaning what, exactly?
Meaning, the vector database retrieves a fact about the system architecture from 3 days ago that is no longer true, and the AI acts on it as if it were current. Furthermore, they have almost zero procedural memory or understanding of future intentions.
Man, here's where it gets really interesting. I mean, we had this illusion of competence. Let's combine this with human systems for a second. An AI agent's memory is just a glorified, leaky filing cabinet that constantly retrieves outdated files.
And meanwhile, our own human reliability metrics are failing for similar reasons.
Yes. It's like having a check engine light on your dashboard that's been taped over because the dashboard is programmed to always show green. We're flying blind.
That is a perfect synthesis of the problem. There's a fascinating piece in our stack today titled The Silent Failure of Reliability Metrics at Scale.
I saw that one.
Yeah, it details how our human-designed service level indicators, or SLIs, gradually lose their accuracy over time. An SLI is the actual metric we track, like the latency of a web page loading.
Right.
But as our systems evolve and grow more complex, the scope of what we measure broadens.
Wait, stop right there. What actually happens when a system's scope gets too broad? Like, why is that a bad thing?
Imagine you're monitoring a massive e-commerce platform. If you broaden the scope to measure all traffic together, a few critical failures, like the checkout cart crashing for 50 users, get mathematically averaged out by millions of successful but irrelevant background requests.
Oh, like users simply loading the homepage image.
Exactly.
Ah, so the math hides the fire. The dashboard shows a 99.9% success rate, so everything looks green, but real customers can't actually buy anything.
It creates a really dangerous false operational confidence. The sources argue the only way to fix this is through tightly bounded instrumentation.
Meaning we have to measure very specific, critical user journeys independently rather than averaging the whole system.
Right. But when you realize that our human system metrics have drifted into meaninglessness, and the autonomous AI agents we're relying on have fundamentally flawed, stale memories, it exposes a massive blind spot in the modern tech stack.
But the sources make a terrifying pivot here. Because for all our obsessing over AI's flawed memory and autonomous attacks, that isn't even the weakest link in the chain.
No, it's not.
The real vulnerability bypasses all this complex AI logic entirely. The weakest link is sitting right at the keyboard.
The tooling supply chain crisis.
Yeah. If you are sitting there listening to this while running an IDE like Visual Studio Code, think about this for a second. GitHub just confirmed a massive security incident where roughly 3,800 internal repositories were exfiltrated.
It's massive.
And it didn't happen through some genius AI hacker chaining vulnerabilities together in milliseconds. It happened because a human developer simply installed a malicious Visual Studio Code extension.
It's the ultimate bypass of all our sophisticated defenses. While customer repositories weren't affected in this specific GitHub incident, it perfectly illustrates the growing existential risk of the supply chain.
Because developers have so much access.
Exactly. Developers have incredible administrative permissions. Their coding environments, their IDEs, have direct, unfettered access to the company's source code, to the execution terminals, and to local security secrets stored on their machines.
So when a developer downloads a random third-party extension to help them, I don't know, format their Python script or change the color of their syntax, they're potentially inviting unknown malicious code straight into the heart of the fortress.
And giving it the exact same security clearance that the developer has.
So let me get this straight. We are spending millions building GenAI SRE tools, orchestrating Terraform digital cages, and running Bazel-backed hermetic environments to stop AI hackers. But an engineer installing a rogue VS Code extension just handed over 3,800 internal repos. Doesn't that make all our high-tech defenses kind of moot if the front door is left wide open by a human?
It absolutely does, which is why the entire industry is in a state of panic right now.
Hmm.
They're desperately shifting from reactive defense to proactive operational control.
How so?
Well, we're seeing this shift play out right now with the new changes to NPM, which is the massive package manager for the JavaScript ecosystem. GitHub just introduced staged publishing and install time controls for NPM.
How does that actually change the dynamic of a supply chain attack?
Historically, if a malicious actor compromised a popular package and published it to NPM, the defense was entirely reactive. You just had to hope a security researcher caught it, reported it, and took it down before your developers accidentally updated their systems and downloaded the malware.
That sounds like a terrible strategy.
It was. Now, with install time controls, organizations have proactive power. They can cryptographically verify packages and set policies on what is legally allowed to be installed in their environments before the download ever happens.
It sounds like we are finally treating the development process itself as a hostile environment.
We have to. It perfectly aligns with the massive new emphasis on CI/CD threat modeling.
CI/CD stands for continuous integration and continuous deployment, right? It's the automated conveyor belt that takes code from a developer's laptop and pushes it to the live servers.
Exactly. And organizations are finally realizing that this conveyor belt is the prime target. They're implementing strict threat models to scan for unauthorized access and malicious code execution before the code ever reaches production.
The sheer complexity of all this is overwhelming. I mean, engineering teams are trying to secure the supply chain, defend against 2-minute AI database heists, build Nova sandboxes, and manage developers who might click the wrong IDE extension. It's forcing the industry to rethink their entire foundational architectures.
They're seeking flexibility, stronger baseline safety guarantees, and tools built specifically for a hybrid future where humans and AI coexist in the stack.
Let's talk about those specific architectural shifts because they're massive. Slack AI, for instance, has been on a 3-year migration path. According to the sources, they started on AWS SageMaker, moved to AWS Bedrock, and by early 2026, they are moving to a full multi-cloud architecture spanning both AWS and Google Cloud Platform.
That multi-cloud strategy is critical for survival right now. When you're building AI-native features, you cannot afford vendor lock-in.
Why is that?
Because the underlying LLM models are evolving too fast, Slack is migrating their entire architecture so they can flexibly route their traffic to access the absolute best-in-class models at any given moment.
Regardless of which cloud provider hosts them.
Exactly, while still maintaining enterprise-grade security.
And it isn't just the cloud providers changing. We're seeing a massive shift in the programming languages themselves. The release of Rust 1.96.0 is accelerating this huge migration of engineering teams abandoning Go and rewriting their systems in Rust.
That's a fascinating architectural trade-off. Go is beloved in the DevOps community for its simplicity and ease of use. But teams are willingly trading that simplicity for Rust, which has a notoriously steep learning curve.
So why make things harder for your developers?
Because Rust offers something Go does not. Stronger compile time guarantees, null safety, and explicit ownership models.
Okay, explicit ownership. Explain that to me like I'm 5. How does that stop an attack?
Think of computer memory like a strict public library. In older languages, anyone can walk in, grab a book, cross out a paragraph, and write in the margins without telling anyone.
Which sounds like chaos.
It is. This leads to memory leaks and vulnerabilities that attackers exploit to inject malicious code. Rust's explicit ownership is a rigid library system where only one specific part of the program is legally allowed to check out a piece of memory at a time.
Oh, I see.
The compiler physically will not allow the code to run if there is a chance two parts of the system might clash over the same memory.
So in a world of autonomous AI hackers trying to find microscopic memory vulnerabilities, ensuring memory safety at the compiler level before the code is ever even deployed is becoming a non-negotiable security requirement.
Exactly. And the infrastructure tools themselves are evolving to accommodate this new reality. There's a new tool mentioned heavily in the sources called Pulumi Do.
Yeah, I saw that. What makes Pulumi Do so different from the Terraform setups we talked about earlier?
Well, Pulumi Do is a command line tool that allows direct create, read, update, and delete operations for cloud resources across thousands of providers. But here is the mechanism that matters. It accomplishes this with a single terminal command.
No way.
Yes, there is no project setup required. There are no massive infrastructure as code files to maintain. There's no state tracking required. It is immediate, stateless execution.
So what does this all mean for you, the listener? It sounds like the entire tech industry is packing its bags for a massive structural road trip. We're fundamentally changing the way we build. Slack is hopping between clouds like they're shopping at different farmers markets for the freshest AI models.
While we are swapping out our underlying vehicles entirely, moving to Rust for better safety ratings.
Exactly. If we synthesize everything we've pulled from the sources today, the trajectory is undeniable. We've moved from a baseline where human developers build things to a world where an autonomous AI agent can execute a complex database heist by dynamically chaining vulnerabilities in under 2 minutes.
And in response, we're desperately building isolated sandboxes like Nova, governed by hermetic Bazel builds, just to safely house our own defensive AI coding bots.
All while trying to manage the false confidence of broad green reliability dashboards, the fundamentally flawed, leaky nature of AI vector memory, and the looming threat of a simple human developer installing a malicious IDE extension that ruins it all anyway.
Right. To survive this landscape, engineering teams are abandoning single cloud architectures for multi-cloud agility. They're trading simple languages for the rigid, compiler-level safety of Rust, and they're creating rapid-fire tools like Pulumido.
It is a complete reinvention of the stack from the ground up.
It is. But I want to leave you with one final thought regarding Pulumido that builds on everything we've discussed.
Okay, lay it on us.
The sources explicitly point out that this tool was designed not just to make life easier for human developers, but specifically so that AI agents can handle quick cloud operations.
Wait, they're designing core infrastructure tools specifically for AI agents to use directly.
Yes. Think about the implications there. If we are intentionally optimizing our core infrastructure tool so that an AI agent can provision cloud resources with a single, stateless terminal command bypassing traditional project files and human-readable syntax entirely, it raises a massive question. Are we reaching a point where the concept of infrastructure as code is already becoming obsolete? Is it being rapidly replaced by infrastructure as autonomous AI thought? If the agent doesn't need to write the configuration code to be reviewed and just executes the intention directly, the code itself disappears.
That is heavy. The code disappears and only the intention remains.
Wow. Well, thank you for joining us on this deep dive into our sources. It's an incredibly wild landscape out there right now, so as you go back to your own projects, keep questioning those green dashboards in your own lives. Look a little closer at the extensions you install. Because, as we've learned today, the construction site isn't just shifting beneath our feet. The tools have woken up, and they are starting to build the house themselves.
Spoken Tech for your ears.